Hello, Math 1. Today we start Chapter 4, which is the first true chapter on geometry. And today we are basically learning how to name line segments and rays and also read them when we're given information in different problems. And one thing you have to know about geometry is geometry was, a subject created by mathematicians that's completely based off of recognizing patterns and trying to determine if those patterns are sometimes, always, or never true. So in the warm-up here, they give you 4 sequences, and they want you to use patterns to try and recognize the next 2 terms in each sequence. I want you to pause the video and try to see if you can determine, the next 2 terms in each sequence. So when we look at number 1, number 1 is a pattern, and if I go from 5 to 10 to 20 to 40, what do I see is happening each time? I am multiplying by 2 each time. So to find the next term in the sequence, 40 times 2 would be 80. And then the next one would be 80 times 2, which is 160. Now the next one, you'll see what's happening each time. Each time I am going down 3. So now the next term would be 6 minus 3, which is 3. And then 3 minus 3, which is 0. Now the next two, these two always crack me up because people get so frustrated with them. And when I look at number 3, O-T-T-F-F-S-S-E, I always give the hint of Count Dracula, because what this is saying is 1, 2, 3, 4, 5, 6, 7, 8. So the next 2 terms would be 9. So this would be N, and then 10. So T. All right. Number 4. After that one, it probably makes it easier. You'll see that this is January, this is February, March, April, May. So it would be J and then J. Okay. So recognizing these patterns is very important. But even more important is knowing what vocabulary is and how to name specific things. So first, we're going to start with a point. A point is a location, right? And it doesn't matter, like if you look at your GPS unit, it doesn't matter how big or small your location is. It's your location. So it has no size. Now we basically plot a point, right? And when we name it just using a capital letter, right? That is key. So when I look here, this A is the name of that point. C is the name of this point, point D, and so on. Now, if you look at it, space is defined as a set of all points. So if we take all of these points and put them together, we create space, okay? Now, looking at this, we talk about a line. A line is basically a series of points that extend in 2 opposite directions without end. Now, looking at this, we put arrows on the end here, right? And because when I look at this line, it tells me it extends in both of those directions forever and ever and ever. Now, what you have to understand is a line is made up of an infinite number of points. When I take all of these points and put them together, they create this line. So what you have to know is a line is made up of millions and millions and millions and millions and trillions of points. When you put them all together, they give you that solid line. Now, when we name a line, there's a couple of different ways that we can name it, right? We can pick any 2 points on the line. So if I look, B and C are on this line, so I can name this line BC with this symbol up above, and it's just a line with 2 arrows on the end. Now, because both points are on the line, it doesn't matter the order in which you write those points. So CB would be a possible name. Then I could do BD if I wanted, or DB. The key is knowing to use the proper symbol above the 2 points. Another way we sometimes write the name of a line is sometimes you'll see a lowercase italicized letter at the end or the middle of the line. So if I see that, I can write the word line and then M, that little italicized letter. Okay, so in example 1 here, name, example A, name that line 3 different ways. So we kind of hinted up there. I'm going to add some more here. I could do CD, I can do DC, right? And I could do, again, BC. For letter B, I can say line L, right? Because this is that lowercase italicized letter. I could use EF, and then I could use FE, okay? So that's 3 different ways to name that line, and you must have the symbol above. Now next, we have a segment. A segment is a part of a line, right? So if we took a line and we plotted 2 points, but we only wanted the part of the line between the 2 points, what this creates is a segment. So a segment is a part of a line consisting of 2 endpoints and all the points between them. So if I look here, again, a segment is made up of millions and millions and millions of points, and when I squeeze them all together, they make the solid line. But the thing about a segment is it starts at R and it ends at S. It does not extend in both directions forever and ever. Now, when we name a segment, we use 2 endpoints with the segment symbol, which is that little bar above the 2 letters. And remember, we only use the endpoints. So one endpoint is R, the other endpoint is S, little segment symbol above. I could reverse the endpoints and say SR like that. So it's 2 different ways you can name that segment. Okay? Now, example 1. When we look at example 1, it says use the diagram to answer the following question. Which? Name the vertical segment. If I look, vertical segment is this segment here. So I can name that one of 2 ways. I can name that PX or XP. Doesn't matter. Now the horizontal segment would be the one that's horizontal, and I can name that segment XQ or QX. When I talk about where these 2 segments intersect, where do they intersect? Well, they meet each other right at this corner here, and that's at point X. And I don't have to write the word point. I could just put X. And that tells me that's the point of intersection. Now, a ray is a part of a line consisting of 1 point, endpoint, and all the points on the line on one side of the endpoint. So if I look here, if I give you a line and I plot a point on here, but I only want to go in one direction, what happens is this here is what we call a ray. It has one endpoint, and then it goes in one direction forever and ever and ever. So it's still part of a line, right? But it's not the entire line. So it extends infinitely far in only one direction. Now, when we naming is key here. When we name a ray, we use one endpoint and the point the ray goes through with this symbol above. And we always point that symbol to the right. Doesn't matter what direction your ray is in. You start with the endpoint. Then you use another point the ray goes through with this symbol pointing to the right. So when I look at example 1 and I want to name that ray, what point is my endpoint? Y is my endpoint. So I start with that. And what does this ray go through? It goes through point X, and I point the arrow to the right. When I look at example 2, what point is my endpoint? C is. That's the endpoint. Now I can name this one 2 different ways because this ray goes through 2 different points. It starts at C, it goes through D, so there's one way to name it. But it also starts at C and goes through E. So I can name it that way also. So knowing the difference between a line, a segment, and an array. Line extends indefinitely forever and ever in both directions. A segment starts and stops, so it has two endpoints, doesn't extend indefinitely. And array starts at an endpoint and goes on in one direction forever and ever. So let's look at some examples here. If I wanted to look at example 3, name the two rays that make up the line. So if I look here, this starts at, if I go C and I say this ray, that would be ray CD, but then I could also say start at C and go this way, so CB. If I put those two rays together, they both start at C and they go in one direction each, and then that creates the line. Now, next, name the sides of the triangle. Well, if I look at this triangle, one side, all the sides of a triangle are segments. So, segment AB, use the correct symbol above. That's one side. And we have side AC. That's another segment. And finally, you have side BC. We would name that segment BC. So remember, the sides of that triangle are segments because they don't extend forever and ever. So when we look here, in this example, I know there are many segments, but when we look at the bigger ones, right, can we name a segment? Well, the one they want you to look for is this one here. That would be segment AB. Next, they want you to name a line. This here is the line because the arrows on each end tell me that that extends in both directions forever and ever. So we would say line CF. Now remember, I can use any 2 points. I could use CG. That would be another way to name the line. I can name it GJ, right? As long as I use a proper symbol above. Now if I had to name a ray, this ray starts at Y and goes in one direction forever and ever. So we would say ray Y G. Or we can say Y X. So next, when I look here, it says where does the ray and line intersect? So if I look at this ray and I look at this line, where do they intersect? Okay, if I look, they intersect at point G. So I just write a G. Now where does the segment and ray intersect? If I highlight the segment and I highlight the ray, if I look, they both intersect right here at point I. So another term we got to discuss is this word collinear. What does it mean if we have collinear points? Collinear means they are all points that lie on the same line. Okay, so when I look here, right, I can say up above C, G, J, and F, right? This point, this point, this point, this point, they're all collinear because they lie on the same line. Now, we could also say Y, I, G, and K, or X are collinear because they're on part of a line. They all line up in a straight line. So collinear just means all the points are on the same line. It brings us to the concept of a plane then. A plane is basically a flat surface that has no thickness, right? It contains many lines and extends without end in the directions of the lines. So when I look at this, although we see this point here, or the sides here, we have to understand that these extend in all directions forever and ever. So next, we need to talk about in geometry what a postulate, or can also be named as an axiom, what these are. These are basically statements that are accepted as being true. I like to say it's just common sense, right? For instance, the first postulate is through any 2 points there is exactly one line. What that is saying is if I draw 1 point, I can draw many lines or an infinite number of lines through that point. But if I plot 2 points, there is only one line that can go through it, and only one line. Okay, so that's what that postulate is saying. Next is if 2 lines intersect, they intersect in exactly 1 point. And if I look here, right, these 2 lines can only intersect at 1 point. And that's because lines don't bend. Now, if 2 planes intersect, they intersect in 1 line. What they're saying here is if I look here, I can see that these 2 planes intersect at line ST. Okay, so all of these are like common sense things that we can assume to be true that we don't have to prove are true. So let's use this as an example. Now, in geometry, you'll see that this stuff can be very difficult for people to see on paper. It doesn't determine the outcome of how well, good or bad, you'll do in geometry. So just keep that in mind as we're going through this. Our points E, F, and D collinear. If I look, do they all lie on the same line? No. Letter B, where does line M intersect line N? Well, if I look at line M, that's this one here, and line N is here, those intersect at point C. Are P and C collinear? Anytime they ask you if 2 points are collinear, the answer will always be yes. Because if I look at P and C, although they're not on the same line, could I draw a line through them? Yes. Now, how about E, F, and C? If I look at E, F, and C, those are collinear. All right. Example 2, name 3 points that are collinear. And if I look here, D, E, and F are collinear. D, E, and F. Name 3 non-collinear. There are many different options, but I can say D, E, and G. Or I can say E, F, and G, right? Those are all non-collinear. Where does HE intersect the plane DGE? Where does this line intersect this plane? If I look, it's at point E. So now, in the diagram, shade plane ABC. ABC, if you look, is the bottom of the box. Okay? That is the bottom of the box. If we had to shade plane EHA, EHA is basically the left side of the box. If I trace the letters E to H to A, it would be this here, as you can see. Now, shade plane EH and C. EHC is the back side of that box. Okay? Then name 2 planes that intersect at BF. So if I look at BF, it's this line here. And if I look, the front side and the right side intersect there. So we're going to say plane EFB and plane FGC. So again, it's the front of the box and the right side of the box intersect there. And that's the thing like you could do too, is if you have trouble with this and you use colored pens, right? If I look, BF is there, and if I use, say, blue, you'll see where they intersect is green. Okay? All right, finally, the last page. What is the intersection of plane HGF? So if I look, that's the top of the box. Okay, and B, C, G, F. That's that there. And if you look, both of those intersect at G, F. So where does plane HEF? HEF is the top of the box, and DAE is right here. If you look, they intersect right up there at line EH. Next, where does HD intersect AD? And if I look, it's at point D. And where does CD intersect plane G, F, B? If you look, that line goes through this right side of the box at point C. So I know this is a long video, but it's a very important video. Okay, so what you're going to do now is you're going to go and work on the 4-1 homework. Okay, let me know if you have questions.